Welcome to Meliora's channel, your go-to place for C# and data analysis tutorials, products hands-on demos, and insider secrets to keep you at the cutting edge of innovation. Our goal is to break down complex tech topics to a level that you will easily understand to supercharge your skills. Without further ado, let's jump right in.
Welcome back. So in the last lecture, we ended off by creating the departments table. And now in this lecture, we're going to learn about constraints and conditions. So we're going to learn about more constraints, how to add the foreign key constraints to our table, and we're just going to explore more conditions using our where clause and other clauses you can add as well. Okay, let's get right in. Okay, so picking back up from where we left off, we have created the department table. And we can see it when we go into our Meliora DB tables, and there it is. So let's go ahead and select all from the department table. But first, let's make sure to tell MySQL that we want to use the Meliora DB for this query. And now we have all the departments, the rows in the department table. So we can see dep ID and all that. So in today's lecture, I'm going to show you how we can add a foreign key constraint on a table. So a foreign key is the column on a table where the values contained in that column are actually primary key codes on a different table. Okay, so to explain this, I want you to take a look at the departments table here. You can see we have different department IDs here, 100 to 600, right? And let's now select all. Just keep that in mind. Let's select all from the employee data table, right? And you can see the department codes here. And if you notice, sometimes we have repeating values in the department underscore code column in the employee data table, whereas these values only exist singularly on the departments table. Okay, in plain English, so you only have one department, but multiple people can belong to that particular department. So let's say it like that. Yeah. So now the foreign key constraint. So what it does essentially is it helps with something called referential integrity. Essentially, if you add a foreign key constraint on a table, it's going to make sure that whatever you're adding into that table, the values actually match the values on the primary key um, column on the main table. So for example, any department code we're adding here, when we add the foreign key constraints, I'm going to show you an example just to further explain this. It's going to make sure that all the department codes listed here actually exist on the department table in the dep underscore ID column. Okay. So let's see a further example of this. And if here I have just prepared a very simple insert statement, insert into the table employee data, the columns here, and then the values. So I want to insert a new staff into this table just to show you what the referential integrity is actually going to be about. We're going to insert 1,000 into the department code area, right? And there is no 1,000. There is no department code of 1,000. It's not linked to any department, but we're going to insert it anyway into the employee data table, and we're going to just see how that is, because right now if we come down, we see no foreign keys right now. Okay, so let's run this insert. Oh, pardon, I selected that. So if you want to run only particular areas of the code, you just highlight them and run. That's also something very good. But I'm just going to don't select any area of the code you can see. So because we only selected that, that's why I ran. So yeah, okay. And now we have successfully inserted this staff and Ami with department code 1,000. You see that now that we don't have any constraints on this department code column, we can essentially insert any department code we want, even those that don't exist. Okay, so I just want to show you that. So now let's go ahead and delete. Let's use this one. Let's go ahead and delete army. So YV1011. So let's go ahead and delete army from that table. So let's go delete from. Okay, so just this very simple delete statement. We're just going to go ahead and delete army from that table, and after we run this, we are then going to go ahead and add in our constraints and then try that operation again just to show you the difference. So delete from employee data where ID is equal to this is army's ID. Okay, so let's go ahead and execute that now, and that's done, and you can see army is gone. Okay, so let's go ahead and add the foreign key constraints. Okay, now, there are two ways to add your foreign key constraints. You can either add it at table creation using the create table statement, and then you just define foreign key, and then in brackets you put the column that is the foreign key of your table, and then you now write references and that. So, but when the table is already created, you can use the alter table statement to add your foreign key as such. You write alter table, and the table that you're going to write here is the table where you want the foreign key constraints to be applied, which in this case, we want it applied on the employee data table, right? And then you're now going to write add constraints. And here I'm using, you can just write alter table, employee data, add foreign key, and then you can, do that. And references and all that, but I like to do it this way just because I like to control what I name my foreign key constraints. Okay, so add constraints and then the name that the constraint is going to have, and then we're now going to write foreign key, and this is where we're now going to put the foreign key of the employee data table. So which key in this table is the foreign key, and that is the dep code. So it's the dep code that is referencing values from the department's dep underscore ID. Okay, and we are now going to we're now going to write references, and they are now going to write the table that it's referencing, and then the column on that table, which in our case is dep underscore ID, right? So this is how we're just going to simply add our foreign key constraint. Okay, so let's go ahead and run. I just use another keyboard shortcut to simply run your queries instead of having to click this all the time is control enter rather. So just control enter to quickly run your queries when you're done typing. So now we've successfully added our foreign key. Let's go ahead and refresh, and there it is. Foreign key employee deps, and there we go. Okay, so now we have Ami, whom we inserted before. As you can see, that's why I didn't want to touch this area. If you remember, you can see here that it was a very successful insert. And we have now deleted her. We deleted her previously before we added this constraint on the other file 10. So now let's try and run this again, and let's see what happens. So now that we have the constraints, will we still be able to put in this value that doesn't exist on the department table? So let's go, control enter. That didn't run. Let's highlight it, and you can see it failed. The first time we did it, it just returned it didn't even run this. It just returned that. And now when we highlight it and force that to run, you can see that we are getting an error. Cannot add or update a child row. Foreign key constraint fails. Okay, so that's the error we're getting. Why? Because this value does not exist on the department table. Okay, and we know, so what if I add a value that does exist? So let's say, I believe we had, okay, let's put someone in department 600 now. Okay, and then let's run all this. And there we have it. Ami has now been added. Department 600, you can see that now, unlike this one here, this did not fail because 600 is a value on the department's dep ID. Okay. So that is what your foreign keys can do for you. And one table like the employee data can have, if we, let's say, have another column maybe for job IDs or many different things as it pertains to an employee in a company, you can have as many foreign keys as needed to make sure referential integrity is upheld in your data, and makes for a very clean entry, and not having to go back and check errors, because at least now you will be sure that every single department code entered here actually exists on the departments table. Okay, so that is how to add your foreign key constraints. So what if we want to drop it? Okay, well, it's that simple to drop a foreign key constraint. You just alter the table, drop foreign key, and then the foreign key that you'd like to drop. It's that simple to drop a foreign key. And it's gone. So this is just some more examples of constraints. So we've seen the foreign key constraints, how to add it, what it actually does, and how to drop it. We've also seen, pardon, the primary key constraint, and this actually comes with two other constraints in tow: the not null, which doesn't which prevents the column from accepting null values, and then the unique, which makes sure that each value entered in the column is not identical to any value already existing in that column. So that's the primary key constraint and the constraint that it automatically adds. And then the default, this allows us to set default values for a column. So if anything is not, if no value is given, then it will default to any value that we set using the default constraint. Okay. Now, you can see that the not null is not the same with the foreign key constraint. So even though we do have referential integrity set up with what we created, it would still be able to accept null values unless we go and apply the not null constraint to that. Okay, so these are just some more examples of constraints. These two we've already used before. This one when we're creating a table, and the default one, which we haven't actually used, but we also use it at table creation with the primary key. You can later actually use the alter table statement to add in the primary key, or to also alter a column to have a default value as well. Okay, so that is it for constraints. So, moving on to the other side of this lecture, which is constraints and conditions. Well, it should actually be more conditions because this is just going to expand more on the where clause. So here we have some more things you can use to really expand the functionality of your where clause. You can use and so that we can test for multiple conditions. We can use not along with is, for example, especially when checking for null values. So where this is not null or is null, and then we have in. In allows you to check for values that are within a list of items. All of this we are going to see. Okay, so let's just jump right back in and see how we can use those new additions to the where clause. So let's go ahead and just do our usual where. Okay, so this is just a very simple query. So select all from employee data where the year of the date of birth column, so it's going to extract the 4-digit year, is greater than or equal to this. And there we go. So greater than or equal to 1980. So we have one that's 1980 here, and then all the ones that are greater. So we have nothing below 1980. Wonderful. If we change this to 1984 and run that again, you can see now we're only getting, there's no 1984, so we're only getting the years that are above that. Okay, so that's the usual thing we did. But what if we want to find where the year DOB is greater than or equal to 1984 and the sex of the person is equal to F? So we want to find all the female staff who are born on or after the year 1984. And that's what we now get. So we're getting filtering here for greater than or equal to 1984, as you can see here. And we're also checking for the sex of the staff to be female. And that's what we get. So there are 2 staff that currently fill this criteria, Andrea and Amy. Okay, so that's how we can use and. Now, I want us to now go ahead and see how we can use the is and not. But to do this, I'm going to use a null value. So before we do anything, I would like us to simply update the employee data table. And I want us to set dep code equal to null where the ID of the individual and thank God we can see YV1011. Okay, so we're going to run a very simple update and we're going to set Amy's department code to null. Okay, and so that's done. And you can see that that worked perfectly. Why? Because again, the foreign key constraint is not the not null constraint. So null values can still enter that column. Okay, so now that we have now set that equal to null, let us now run a very simple check. So let us go ahead and select all. First of all, let's select all from employee data, right? So that we can see the full table. And now we can see Amy being the only one within null department code. So let's go ahead then and now add our constraints. So if we say where dep code is null, right there. So that's our is. And we run that. Only one person's department code is null, which is Amy. So you see that? And if I now say is not, adding the negator there, is not null, These are is null and is not null are beautiful ways to either check for or omit null values in your queries. And if I now go ahead and run that, you can see that Ami is no longer being returned because her department code is in fact null. Okay. And the last addition to our conditions we are going to add is the in. Okay, so I'm going to do this make it very simple. So in allows you to check for columns whose values are within a certain list of values. So for example, if we write where year DOB, right, in, and we can just list the years that we want returned. So let's say 1970, 1990, 1992, and let's say 1980. 5. So we've provided a whole list. So I want years where the year of their birth is within the list of these numbers. So that's in. And this is what we get. So we get 1985, 1990, 1992. So you can see how in is a very powerful clause to really filter for your table for a whole list of things. And it's not only let's say first name, and let's just pick people whose first names we already know are there. Andrea, let's say I don't think I have any Tom, but let's just put Tom. So things like this, and oh my gosh, do not forget that these are strings. Okay. And if we now filter, we can see we got Ahmed, we got Andrea, we got Ami. Okay. So wonderful. So I just gave you, so we filtered the year DOB and we got the list of numbers. We can also do this for department code as well. And I'll leave you to try and write that query on your own and get department codes using your in for department codes 100, 500, and 300. Okay. And so, yeah, that now brings us to the end of this lecture. Okay, thank you very much for watching the lecture, and I'll see you in the next one. Goodbye.